When we're programming, sometimes we need to store little pieces of data so that we can use it again in our program, and sometimes even change what that data is as we sort of keep a record of what's going on. For example, in a computer game, we might have a score, and that score might keep changing as we get more points as we play the game. So we need to store what the score is, and we do that in something called a variable. Now, a variable is a place in memory where a program can store a piece of data that can change while the program's running. So a variable is just a little place to hold the data. So let's make a variable here, score, and we just say what it's equal to. So maybe our score is 200. So I just put the data into it using the equals command, and that's called assigning. I put a value into a variable is called assigning. So I do that, and nothing appears to happen. But I can now retrieve that data. So for example, if I wanted to print the score, I could go print and the score, and it prints out 200. And the key thing of a variable is that it can change. So I could go score equals 300. So assign a new value, and I could print score again, and now it says 300. And I can even manipulate it in a more interesting way. I could do something like score equals whatever the score was before plus 10. And what that would do is add 10 to the current score. So it's done that. So let's do print score now. And we get a score of 310 because it's added 10 to what was already in the score. So a variable holds a piece of data, allows you to retrieve it and use it. It also allows you to change it while the program is running. Now, we can store lots of different things in variables. It could be scores, it could be names, it could be points, it could be totals, it could be averages, it can be all sorts of different pieces of data. But what is very important is that we give our variables meaningful names. So the name of a variable should always describe the data it contains. So in the example we've just looked at, we were storing the score, so we called the variable score. Now, say I wanted to store the first name of a person. What I couldn't do is call it something like this, first name, which is a shame because that seems like quite a descriptive name. It's telling us that this variable holds someone's first name. But let's see what happens. I'm calling myself Bob. Let's press enter, see what happens. And it says syntax error. Now, what that means is we've not followed the rules of the language. And one of the rules of Python is that you can't call a variable anything that begins with a number. So you've got to use letters. You can use numbers in the name, but you can't start the name of your variable with a number. So, okay, so let's use the word first and name. So let's call it first. First name equals Bob, like that. And again, we get another syntax error. This time it's highlighting the word name. And the rule we've not followed this time is that we've put a space in the name of the variable. So it's seeing the word first and it's seeing the word name. It doesn't know what either of those are because they're not commands. So it's now got stuck. It says, I don't know what you want to do with first. You've just put first and name. I'm guessing first is a variable, but then I don't know what you want to do with it with name because I don't know what name is. So it's telling us we're not following the rules of the language because we've put that space into the name. So let's get rid of the space. And to make it easy to read, we're going to use something that we call Camel Type. So watch me type. I'm going to call it first. Now notice I didn't use any capital letters, but now I am. I'm not going to put a space in. I'm going to put a capital N for name to show the beginning of the next word. So this gets rid of the space, but it sort of makes it easy to read. The capital shows that there's a new word beginning there. So this is what we call Camel Type because the capital letter creates like a hump in the name. So there we are. There's our variable. We're starting with lowercase, capital N to show the new word. So let's put equals Bob. And that's taken that in. And so I can now print first name. Spell first right. First name. And it prints out the first name, which was Bob. So it's a general rule is we don't use capital letters in the names of our variables except when we're using Camel Type to show the beginning of new words within the name. Now there's one more rule, bit of syntax, one more rule for our language, and that is we don't use the name of any command words. So for example, I don't call a variable print. Because if we do that, it works. The problem is print no longer works. So say I wanted to print hello world. What should happen is when I press enter, it should say hello world. Does it happen? No, we get an error. And that's because we've changed what print is by assigning this piece of data, by putting Bob into it. We've changed what print is. We've told print, instead of being the little program that prints text on the screen, we've told it to be equal to Bob. So now we get this error and I can no longer print in my program. So when we're programming, we never use keywords. We don't start our variable names with a number, and we don't have any spaces, and in fact we don't use any other characters. We just use text and numbers, although we don't start with a number. So that's the names of our variables. So let's assign some data. Let's have a look and put some data into our variables. Right, so what I've done here is I've created a little program where I'm putting some data into our variables. Now, putting data into a variable is called assigning. So assigning some values, and we use it as a little equal sign to show that that's what we're doing. Now, you'll notice that I've got different ways of assigning. Here, Bob goes in quotes, and that's because Bob is just a bit of text that I've typed in. And Bob is a string. It's a string of text characters, ASCII text characters, that we're putting into the variable. So when this is stored in our program, behind the scenes, the computer has to turn everything into binary. So it has to take each of these letters, look it up in the ASCII table, what's the value, and then turn it into the binary code so that it can be stored in the variable. And then when we read it back, it does the opposite. It takes the binary, looks up the number, sees what number that is, and shows us the character. Age here is different. I've just put 14. I don't need quotes. I could put quotes, in which case it would be the text 14, but age is a number, and so we want it stored as a number. So it takes the 14, just turns it into binary as the binary value 14 and stores it in the variable. Now, this is an integer. It's a whole number. So that's one way of doing it. Height here is a different number. This is a number with a decimal point. In mathematics, we would call that a real number, not an integer, but a real number. In computing, we also call it a real number, but Python calls it a float. It's called floating point because it has a decimal point in it that can move around to show different values. So that's height. When we look at enjoy school equals true. Now this looks like a word. It looks like it should be a string, but you either enjoy school or you don't. So there's two values there. It's either true or it's false. So we call that a Boolean value because it is a logical statement. It's either true or it's false. It's a Boolean value. And that doesn't need any quotes around it, but it does need a capital letter. So if I was to put that in with a little lowercase, it doesn't understand the word, so that breaks the syntax rules, so we need to put a capital T, and likewise we could put that as false, they don't like school, and again it needs a capital F to show that it is a logical Boolean value. So all of these are different variable names with some data assigned. If I was to run this, I just need to save it first. Nothing happens because all we've done is put some data into our program. We can get the data out, perhaps by printing. So we could say print, let's print height. And if we run it now, it says 1.4, just as we would expect it to do. Now, the computer does store these in different ways, and as soon as we assign the value, Python behind the scenes checks to see what type of data you're putting into the variable, and then it stores it in the right way. And we can get Python to actually tell us what type of data something is by using the word or the command type. And I'm just going to put like type first name, the name of the variable. And it's going to print out now and tell us what type first name is. So let's just run that. So I'll save it, and then we can see the output, and it says it's classified as a string. So we have got a string. First name is in fact a string. So I'm going to do this now for all the other variables, just so that we can see that they are indeed being stored in different data types. So let's just put age in there and height in that one, and enjoys school there, and the last one was favorite color, like so. Oh, I'm going to match our type to it, and if we run this program, okay, you'll see it's got string, integer, float, Boolean, and another string just to finish off. So each variable stores data in the correct data type for the information that we're giving it. So our choices are string, integer, float, Boolean, and that's all we've got. So hopefully now you know the rules for naming a variable, that putting data into a variable is called assigning a value, and when data is stored, it's stored as a different data type depending on the type of data you put into the variable.